Hi, Mr. Bennett here, guys. Today we're going to be looking at another example where you use equations of lines and the distance formula. So for this one here, imagine we've got some sort of pipeline or whatever, and we want to tap into that pipeline. And what we want to do is we want to make sure that at least two houses, say they're tapping this pipeline, that they're going to pay the same amount. Alright, so we're going to put a pumping station at T or some sort of transition point there. Now, obviously for that to be fair, what we need to say is the distance of AT would have to be the same as BT. Alright, so if we made those two things equal, then the people at B and A would basically pay the same amount, wouldn't they? Alright, so to actually work this out, what we need to do is use the distance formula. Alright, so if we just use that, right, so the first thing you might go is x coordinates 4, take 1, and we square that, and then it's going to be A take 6, we square that. That distance has to be equal to the same distance as this one over here, which would be 4 take 8 squared plus A take 2 squared. Right, so just using a distance formula. Now, because we're squaring both sides, we can get rid of the brackets. Right, 4 take 1 squared, that's going to give me 9. 3 squared is 9. And then we can fall this bit out over here, and we can say that's going to be A squared. Right, take 12A plus 36. Right, on this side over you got 4 take 8 is going to give you negative 4 squared, that's going to be 16. And you're going to get A squared, take 4A plus 4. Alright, so because we've got an A squared on both sides, we can cancel that out. That goes. And then what we need to do is bring all of our numbers and all of our A's to one side. So if I bring the numbers to the left hand side and the A's to the other side, right, so we've got 9 plus 36 is 45. And then we're going to have take 20, that's 16 plus 4, and that's going to be minus 4a plus 12a. So then we've got 25 is equal to 8a, so therefore our a value is in fact equal to 25 divided by 8. So we know the point there, which is going to be so the point that we need to put the pipeline, or the pumping station or wherever it might be, would be 25 on 8. Alright, so that gives us our coordinate. Now if we know that's our point, if we want to work out what it's going to cost, then we can just work out simply the distance between point T and A, and then that will give us that particular length will be the same as TB. Alright, and you can actually work out that cost. So I'm not going to do that now, but this is a sort of typical question that you might get in a test, and it might sort of give you a line. It doesn't have to be a vertical line or a horizontal line, but quite often it will be, something like that, just to make it a little bit simpler for you. So this one here, I have to think it's a little bit different from finding the midpoint. It's not necessarily the midpoint. And it's not necessarily the perpendicular line that's going to be the shortest distance. And obviously if you did B, it would be short to go straight across and then straight across from A, but that means that you're going to have to put in two pumping stations if it's like a pipeline, and that's probably going to cost a lot more than running an extra bit of pipeline. Alright, so good application. This is a really good example of using your distance between 2 points. Alright, so you're bound to get a question like this in your test, so make sure you know how to do that.